given that f double prime of x equals 6x squared plus 6x plus 2, and that f of negative 1 equals negative 1/2, and f prime of negative 1 equals 2, find f of x. Okay, so we're given a second derivative, and we want to take this second derivative and make it a zero derivative, just the normal function. So we're going to integrate twice. So f prime prime of x equals 6x squared plus 6x plus 2. This doesn't seem that bad because a lot of these are just going to be the power rule. So this would be 6x cubed over 3 plus 6x squared over 2. You just raise the x to 1 power and then divide by the power that you raised it to. So then we'll have 2x, which is 2x to the first divided by 1. But C. But now we also know that f prime of negative 1, which would be 6 times negative 1 to the third over 3, plus 6 times, I can do better than that, 6 times negative 1 squared over 2, plus 2 times negative 1 plus c equals 2. Simplifying this, we have negative 2, because 6 times negative, so negative 1 to the third is negative 1. Negative 1 times 6 is negative 6. Negative 6 divided by 3 will be negative 2. So 6 times 1 will be positive 3. And then this will be negative 2. Plus c equals 2. So we have negative 4 plus 3, which is negative 1, plus c equals 2. Therefore, c equals 3. Okay, we got that. So we'll rewrite f prime of x. F prime of x, we now know is, let's see here. I'm going to simplify 6 over 3 as 2. So we have 2x cubed plus 3x squared plus 2x plus 3. Okay, now we need to take the integral one more time, and we'll get f of x. F of x equals 2x to the fourth over 4 plus 3x cubed over 3 plus 2x squared over 2. This looks fairly convenient. Plus c. Okay? And we also know that f of negative 1 equals 1/2. Negative 1/2. So we'll say that f of negative 1 equals, check to make sure I'm getting that right, f of negative 1, yep, we are. So we have negative 1 to the fourth will be just 1. So this will be 1/2 plus 3 over 3 is 1. So we'll have plus negative 1 plus negative 1 squared is just positive 1 plus 3 times negative 1, which will be negative 3, plus another c, which is distinct from the previous c. And I think this equals what? Negative 1/2? Negative 1/2. Negative 1/2. Okay? Change color. More simplification. So the negative 1s will cancel. We'll have a negative 3 here. So we have c minus 3 plus 1/2 equals negative 1/2. Moving the 1/2 over to the other side, we have negative 1. So negative 1/2 minus negative 1/2 is negative 1. So c equals 2 when we add 3. So our final answer, f of x, this has been more work than I expected, is x to the fourth over 2, 2 over 4, plus x cubed plus x squared plus 3x plus 2. Okay? Copy this real quick, drag it over to the appropriate location, see if we have something that kind of sort of approximately fits it. So we have this, which looks really close, but maybe I missed something. So we'll go back real quick. So we have c minus 3. I see what happened. Okay. So what I think is, this guy up here is actually supposed to be positive 1/2. And so what happens is down here then we have positive 1/2 gives us 0, which gives us c equals 3, which gives us over here c equals 3. And so the answer should be this guy right here. So to backtrack real quick, we were given an equation and we're given the second derivative and two initial conditions. And we just work down from top to bottom. So take the integral of the second derivative, which will then give us the first derivative with a constant c, plug in our initial condition to find that constant. So now we have the first derivative, f prime of x. We then do the same thing, take the derivative, or correction, integral of f prime of x. We get f of x, still with that constant, with another constant c, plug in the initial condition, and solve. So that's how we do double integration with a couple of initial conditions given to us. That's how this problem solved. See you on the next problem.